Continuing our discussion on integrating rational functions, we have integral of x plus 6 over x squared plus 8x minus 20 dx. And I've already factored the denominator. It's x plus 10 times x minus 2. And since we have two binomials, we can break down our original fraction into two partial fractions. So a over x plus 10 plus b over x minus 2. Now we need to find a and b respectively. The common denominator, least common denominator, is x plus 10 times x minus 2. So we multiply the entire equation by x plus 10 times x minus 2 and go fraction by fraction to see what cancels out. In the first fraction, everything cancels, leaving us with just x plus 6. Second fraction, the x plus 10s cancel, leaving us with a times x minus 2. And the last fraction, the x minus 2's cancel, leaving us with b times x plus 10. Now you can match up the like coefficients and solve for a and b using a system of equations, but maybe a simpler way is to use the zeros to find a and b. What will make this binomial 0 is when x is equal to 2. So everywhere you see an x, plug in 2. So we have 2 plus 6 equal to a times 2 minus 2 plus b times 2 plus 10. Now in the middle, the 2 minus 2 goes to 0, so that middle part disappears. And we have 8 equal to 12b. Divide both sides by 12, and we get 8 over 12, which reduces to 2/3 for b. Let's do the same thing to find a. So let me erase all of this and we'll focus on using the other 0. Now, second parentheses, what would make that binomial 0 is when x is negative 10. So this time around, everywhere you see an x, plug in negative 10. Well, we know that this last part will go to 0. And we're left with negative 4 equal to negative 12a. And divide both sides by negative 12 and reduce. And we get 1/3 for a. So let's go back to the very top and plug in a and b respectively. And once we plug in a and b, we can integrate each fraction pretty easily. Alright, so a was 1/3, so that would be integral of 1 over 3 x plus 10 dx plus the integral of b is 2/3 times x minus 2 in the denominator dx. And at this point, it's simple u substitution. For the first integral, let u equal to x plus 10. And when we take the derivative of both sides, that gives us du equal to dx. And for the second fraction, let u equal to x minus 2. And du is still dx. So plugging in our u and du respectively, we have now, for the first fraction, 1 over 3u du plus second integral 2 over 3u du. Now, the integral for each fraction is the same. The first one, 1 over u du, the integral of that is natural log. So we have 1/3 natural log absolute value of u plus 2/3 natural log absolute value of u plus c. And the last step is to back substitute what each u was. So our final answer is 1/3 natural log absolute value of x plus 10 plus 2/3 natural log absolute value x minus 2 plus c. In the next video, I will show you one more example using from lesson 19, partial sums.